Okay, so your due now today is actually over something from your homework that's due today. And then also I gave you some practice problems like it on your homework for tonight, okay? On your due now, I asked you to find the slope and length of each side, classify the triangle by sides and angles, show mathematical proof. I even said split up the work with friends. Because how many sides does a triangle have? Three sides, right? Let's call this A. Let's call this B. Let's call this C. Triangle has three sides. So how many slopes are you going to need to find? Three. And how many distances or lengths are you going to need to find? Three. So that's why I said split up the work with friends. What I would do here is I would say, okay, I'm going to look at my slopes first. You're going to have to find the slope of AB. You're going to have to find the slope of BC. And you're going to have to find the slope of CA. And then I'm going to have to do distances or lengths. I need to know how long AB is. I need to know how long B to C is. And I need to know how long C to A is. Okay, slopes. Let's do slopes first. Slopes, we can use rise over run, or you have a slope formula, right? So your slope formula is y2 minus y1 over x2 minus x1. Everybody should be pretty good at slopes. When I do the slope of A to B, I go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the slope of A to B is 6 over 11. Now do the same thing with the slope from B to C. Well, the slope from B to C, I'm actually going to have to go from C to B up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then over 1, 2, 3, 4, 5, 6. So my slope from B to C, since I still went up, is 11 over 6. And the slope from A to C, down 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5. That's negative 5 divided by 5, which is just negative 1. I'm going to come back to the slopes in a minute, okay? Let's go look at lengths. When I say length, I'm talking about the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I do A to B, negative 4, negative 1, that's my x1, y1. When I do B, that's going to be my x2, y2. So when you plug it into your equation, you end up with the square root of x2 is 7. So that's 7 minus negative 4, which makes 7 plus 4 squared, plus sign y2 minus y1, that's 5 and negative 1. 5 minus negative 1 is 5 plus 1 squared. So when I work this out, I get the square root of, what's 7 plus 4? 10? 11. Okay, good. So 11 squared plus 5 plus 1 is 6, 6 squared. And so that's 121 plus 36. You get the square root of 157. You can't reduce that radical because 157 is prime. Well, since A, B, and BC have the same slope, guess what? They have the same length. Square root of, man, every once in a while my pen decides to stop working. Square root of 157. And then C to A. That's going to be the square root of 50 after the distance formula. But what can I do to the square root of 50? The square root of 50 is actually just the square root of 25 times the square root of 2. Do you guys agree that 25 times 2 is 50? What's the square root of 25? So this actually reduces to 5 square roots of 2. Okay, I brought back stuff from unit 1s, 2, and 3. The reason why I brought all this stuff back up is because to talk about classifying triangles. Well, if I look at AB and BC, what do you notice about AB and BC? The lengths. The lengths are the same. If the lengths are the same, that means that this triangle has 2 congruent sides, which makes it an isosceles triangle because AB and BC are congruent to each other. Because line segment AB is congruent to line segment BC. Over here with slopes, though, the only thing we can tell from the slope is either if lines are parallel or lines are perpendicular. Well, obviously in a triangle, we're not going to have parallel lines. So that leaves perpendicular, meaning is this a right triangle or not? If this triangle is a right triangle, it's going to have opposite reciprocal slopes. Well, the only 2 slopes that are somewhat opposite reciprocal are the slope of AB and BC, but those are just reciprocal slopes, meaning the fractions just flipped. But they're both positive, so they're not opposite reciprocal. In order to be opposite reciprocal, the fraction has to flip. One has to be positive and one has to be negative, and that is not the case here, right? So the only thing our slopes tell us right now is that this triangle is not a right triangle. That leaves us with 2 options. The 2 options are acute or obtuse. To figure out if this triangle is acute or obtuse, we use the formula, Pythagorean theorem, a squared plus b squared, and we have to figure out if that's going to be less than, greater than, or equal to c squared. Normally, I tell you guys that the c is the longest side, but in this case, on our lengths, we actually have 2 sides that are equal and 1 side that's not. So the square root of 50, or 5 square roots of 2, is the smallest side, so that has to be my a. So we're going to write the square root of 50 here, squared, plus the square root of 157 squared. We don't know if that's going to be greater than, less than, or equal to c squared, which is also the square root of 157 squared. So we're going to put a question mark here still. If you type this in a calculator, on this, the left side, what if I told you you're going to end up with 207? No square root signs. Well, that's because the squared and the square root sign cancel, so you're left with 50. And then 157, the square root of that squared is actually just 157. So on that side, you're just going to end up with 207. And on the right side of the equal sign is 157 squared, the square root of 157 squared. Well, that square root sign and the square cancels, so you're just left with 157. So is 207 less than, greater than, or equal to 157? Hopefully you're saying greater than. If it's greater than, that proves that this triangle is an acute triangle. So this triangle's special name